Something is wrong with the universe. Not broken, just indifferent. Vast beyond any honest comprehension. Governed by forces that were never calibrated for survival. And filled with objects so extreme they exist at the very edge of what physics can describe. You will never visit these places. But understanding what they are, truly understanding, changes something in how you see the night sky. It stops being beautiful. It starts being honest. There are stars in this universe that have already died, collapsed, compressed, reduced from something millions of kilometers wide into a sphere roughly the size of a metropolitan city. But not all of these remnants are equal. A small fraction of them carry something that the rest do not. A magnetic field so grotesquely powerful that it occupies a category entirely its own. These objects are called Magnetars, and they represent one of the most quietly catastrophic phenomena the cosmos has ever produced. To understand the scale, start with something familiar. Earth's magnetic field, the invisible shield that deflects solar wind and allows compasses to function, measures approximately 0.0005 Tesla functional. Protective, completely unremarkable by cosmic standards. A Magnetar's magnetic field reaches up to 100 billion Tesla. Not stronger in the way that one mountain is taller than another, stronger in the way that erases the comparison entirely. Imagine you were positioned 1,000 kilometers from one, that is closer than the distance between many major cities on this planet. At that range, you would not be burned. You would not be crushed. The magnetic field would begin dismantling you at the atomic level, pulling electrons free from their nuclei before a single nerve signal could register what was happening. The structured matter that composes a human body would dissolve into a dispersed stream of charged particles. Not death in any conventional sense. More like an organized thing becoming permanently unorganized. And this is before accounting for the radiation. At distances of hundreds of thousands of kilometers, the X-ray and gamma output from an active magnetar would penetrate any shielding that human engineering has ever conceived. There is no thickness of lead, no configuration of alloys, no spacecraft hull that survives prolonged exposure to that energy density. The radiation does not care about the barrier. It moves through it. What makes magnetars uniquely unsettling is not just their continuous output, but what they are capable of in a single moment. Beneath the surface of a neutron star lies a crust of extraordinary rigidity, denser and harder than anything that exists in ordinary matter. But the magnetic field pressing against that crust from within builds stress over time, and occasionally the crust fractures. This event is called a starquake, and its consequences are almost impossible to frame in human terms. The energy released in the first millisecond of a major starquake exceeds the total energy output of our sun across 100,000 years. What follows is a gamma-ray burst of such intensity that it propagates outward for thousands of light years in every direction. In 2004, a magnetar located approximately 50,000 light years away, on the opposite side of the Milky Way, released one such burst. The distance was enormous, and still the pulse was energetic enough to measurably compress and partially ionize Earth's upper atmosphere. Scientists detected the effect in real time. Had that same event occurred several thousand light years closer, the consequences would have extended well beyond the atmosphere. The surface of this planet would have faced direct exposure to one of the most energetic events in the observable universe with zero warning and zero recourse. Magnetars do not persist. On cosmic timescales, they are transient, burning through their magnetic energy over tens of thousands of years before quieting into ordinary neutron remnants. But while they are active, they sit in the dark between outbursts like pressure building behind a wall. Silent, patient. And the nearest known candidates are not as far as the number 50,000 light years might make you feel. Pull back now from the catastrophic and immediate and consider something stranger. An anomaly not in what explodes, but in what is simply absent. The oldest light in the universe is called the cosmic microwave background. It is the thermal afterglow of the Big Bang, a faint wash of radiation that permeates the entire sky with near-perfect uniformity. Cosmologists have mapped it in extraordinary detail, and what they found is largely what the models predicted, a smooth field of ancient energy with small natural variations scattered throughout. Except for one region, one patch of sky, located in the direction of the constellation Eridanus, where the temperature of this ancient radiation drops by approximately 70 microkelvin below its surroundings and spans an area nearly 10 times the apparent size of the full moon. 70 microkelvin sounds like nothing. In the context of the cosmic microwave background, it is a profound deviation. The statistical probability that this anomaly arose from random fluctuation falls below 1%. It is not a measurement artifact. It has been confirmed across multiple independent analyses using separate instruments. The cold spot is real, and it does not fit neatly into standard cosmological models. One explanation involves a supervoid, a region of space so depleted of matter that it spans over 1 billion light-years in diameter. When light passes through such a void, it loses a small fraction of its energy through a mechanism tied to the accelerating expansion of the universe. The radiation emerging on the far side appears cooler, and in the precise direction of the cold spot, astronomers have identified one of the largest known voids in the observable universe, stretching close to 1.8 billion light-years across. But the supervoid does not close the equation. It accounts for a portion of the anomaly. The remaining temperature deficit persists in the data, unresolved, unexplained, and resistant to current theoretical frameworks. This is where cosmology intersects with something that feels less like science and more like philosophy, though the mathematics behind it are entirely serious. Inflationary theory, one of the most well-supported frameworks for understanding the early universe, naturally gives rise to the possibility of a multiverse, not as a metaphor, as a physical consequence of the same expansion that shaped everything we can observe. In this framework, our universe is one bubble among an uncountable number, each sealed within its own space-time, each evolving independently. These bubbles do not interact, except that under specific conditions at their boundaries, two bubbles may have grazed each other in the earliest moments of existence. And if they did, that contact would leave a signature, a region of altered energy density embedded in the oldest radiation we can measure. The cold spot may be that signature, not a void, not a coincidence. A scar from contact with a universe that exists entirely outside anything we can ever observe, verify, or reach. There is currently no instrument capable of confirming this. There may never be. The anomaly simply persists in the data, colder than everything surrounding it, at the edge of what current physics can explain. There is a direction in space that everything in our local universe is moving toward, not drifting, being pulled. Galaxies that formed billions of years ago, clusters of hundreds of thousands of stars, structures so large they dwarf anything the human mind was designed to process. All of them flowing steadily and relentlessly toward a single region roughly 250 million light-years away. Our galaxy is among them. The Milky Way, along with the local group, along with the Virgo cluster, is being drawn toward this point at approximately 600 kilometers per second. You have been moving toward it every second of your life without ever feeling the motion. This region is called the Great Attractor, and the most unsettling fact about it is not what it is. It is that we still cannot fully see it. The Great Attractor lies directly behind the densest portion of our own galaxy, the galactic core, packed with dust clouds and gas filaments and billions of overlapping stars. This region, which astronomers call the zone of avoidance, absorbs and scatters optical light so completely that ground-based telescopes see essentially nothing in that direction. For decades, one of the most gravitationally dominant structures in our cosmic neighborhood was hidden behind our own galaxy, like something placed just out of reach. Infrared and X-ray observations eventually pierced part of the obscuration. What lies beyond is a dense concentration of galaxies known as the Norma Cluster, embedded within a far larger superstructure called Laniakea, a supercluster spanning over 500 million light-years, of which the Milky Way is itself a member. We are not watching this system from outside. We are inside it, being shaped by it, with no vantage point that allows us to see the full picture. But the Norma Cluster alone does not explain the numbers. The gravitational calculations, when applied carefully, suggest that the observed flow of matter toward this region is stronger than the visible mass can account for. In 2016, a study published in the Astrophysical Journal identified an additional massive structure further behind the galactic plane, dubbed the Vela supercluster, which may be contributing significantly to the gravitational pull. And yet, even with Vela included, some researchers argue the models are still incomplete. There may be additional mass concentrations deeper in the zone of avoidance, structures we have never seen and cannot yet reach with any instrument we currently possess. The Great Attractor is not a black hole. It has no event horizon, no singularity, no defined boundary. It is a region, immense, gravitationally dominant, and partially invisible, that has been redirecting the trajectory of the Milky Way for billions of years. The journey toward it will take far longer than the current age of the universe to complete. And yet the pull is real, measurable, and ongoing. Something out there in the dark is patient in a way that no living thing can truly appreciate. Now consider darkness itself, not as an absence, but as a physical property of an object that should not, by every intuition, be dark at all. Tres negative 2b is a gas giant. In size, it is comparable to Jupiter, a world of swirling atmosphere with no solid surface, dominated by pressure and chemistry on a scale that makes Earth's weather systems look trivial. It orbits its host star at a distance so close that a single year there lasts less than 2.5 Earth days. At that proximity, the stellar radiation heating its upper atmosphere is immense. By every reasonable expectation, a planet this close to its star should be bright, reflective, luminous, visually striking when observed in transit. Tres negative 2b reflects less than 1% of the light that strikes it. The moon reflects approximately 12%. Fresh black asphalt reflects around 4%. Black acrylic paint reflects around 6%. Tres negative 2b absorbs nearly all incoming light and returns almost none of it. It is, by measurement, the darkest planetary body ever discovered. Darker than coal, darker than any naturally occurring material cataloged on Earth, darker than anything of comparable size in the known universe. The atmosphere contains compounds capable of absorbing light, sodium vapor, potassium vapor, and possibly titanium oxide. And these substances account for part of the measured absorption. But the physics of those compounds applied honestly to the models do not fully explain an albedo this low. Something additional is operating within that atmosphere that current spectroscopic analysis has not resolved. A 2011 study in the monthly notices of the Royal Astronomical Society confirmed the albedo measurement and acknowledged that the precise absorption mechanism remains an open question. The darkness is real. The explanation is incomplete. What makes Tres negative 2b genuinely disturbing is not the darkness alone, but the contradiction embedded within it. Its atmosphere is heated to over 1,000 degrees Celsius by a star it nearly grazes. At those temperatures, the planet emits a faint thermal glow in the deep red spectrum, not enough to see with the naked eye, but detectable. It is simultaneously one of the hottest planetary atmospheres ever recorded and the least reflective object of its kind. A world on fire that the universe has made nearly invisible. It absorbs everything and returns almost nothing, which in a different context sounds less like a planet and more like something else entirely. And that something else is where this ends, not with a bang, but with a boundary. A black hole has no surface, no wall, no visible edge. It is not a hole in space in any physical sense. It is a region where gravity has become so concentrated that the escape velocity exceeds the speed of light, and at a specific distance from the center, determined entirely by the object's mass. There is a threshold. Cross it in any direction, and the geometry of space-time itself ensures that every possible path forward leads only inward. This threshold is called the event horizon, and it is perhaps the most philosophically complete trap that the universe has ever constructed. For a black hole carrying the mass of our sun, this boundary would exist at a radius of roughly 3 kilometers. For the supermassive black hole at the center of the Milky Way, Sagittarius A, with a mass approximately 4 million times that of our sun, the event horizon extends across a region larger than the distance between Mercury and the Sunday. The black hole at the center of galaxy M87, imaged directly by the Event Horizon Telescope in 2019, has a mass of 6.5 billion solar masses. Its event horizon is larger than our entire solar system. Imagine falling toward one. To an observer watching from a safe distance, your descent would appear to slow as you approach the horizon, a consequence of gravitational time dilation, where time itself runs slower in stronger gravitational fields. You would appear to redden dim and eventually freeze at the edge, your image growing fainter across billions of years without ever quite disappearing. From your own perspective, nothing dramatic would mark the crossing. No physical impact, no visible boundary. You would pass through a region of space that looks identical to any other, and you would not know, in that moment, that every future path you could take now leads to the same destination. What follows is called spaghettification, a term that sounds almost gentle for what it describes. The gravitational gradient between the part of your body closest to the singularity and the part furthest from it becomes so extreme that the differential force stretches matter lengthwise while compressing it laterally. Atoms are pulled apart, structure breaks down. What enters the black hole as a coherent object exits that process as a thin, spiraling stream of elementary particles drawn toward a point of infinite density where the equations of general relativity produce results that have no physical interpretation. A singularity, where space and time cease to have the properties we assign to them, and where no theory currently in existence can describe what actually occurs. The Event Horizon Telescope gave us an image of that boundary for the first time, a glowing ring of superheated infalling matter surrounding a perfectly dark circle. Not simulated, not illustrated, observed. That dark circle is not empty space. It is the region beyond which no information, no light, no signal of any kind has reached us. Whatever happens inside it, we will never know. The universe has placed it beyond the reach of any question we can ask. And perhaps that is the most honest summary of everything covered here. Magnetars that dismantle matter without touching it. An anomaly in the oldest light in the universe that may be a bruise left by another reality. A gravitational force pulling our galaxy towards something we cannot fully see. A planet made of near-perfect darkness. A boundary where physics stops producing answers. These are not edge cases or theoretical curiosities. They are real, measured, confirmed features of the universe we actually inhabit. The cosmos was not constructed with observation in mind, and certainly not with survival in mind. It simply exists on scales and at energies that make the entire history of life on Earth something closer to a brief, unlikely accident than a destination. The night sky is not a ceiling, it is a depth, and most of what lies within it has never heard of us.